Hi, my name is Brian.
My name is Raimundo. My name is Henry.
My name is Louise.
And my name is Caitlin, and we are from
Harmony Public Schools.
Today, for our PBL demonstration, we will be calculating the period and gravitational acceleration of a simple pendulum.
In our experiment, our primary focus will be on the topic gravitational acceleration. Gravitational acceleration, generally symbolized as g, is the acceleration of an object caused by gravitation. In other words, it is an expression used to determine the intensity of a gravitational field. It is expressed in meters per second squared, and its value on Earth is 9.81 meters per second squared.
We will also investigate the period or oscillation of a simple pendulum. How is it affected by masses of different amounts, or how is it affected by string lengths of different amounts?
The period, or the time for a pendulum to start at one point, travel to the opposite point, and then return to the original location, will be calculated by the formula T equals 2 pi multiplied by the square root of the string length over the value of g, where T is the period or the time for a mass to return to original position, and g is roughly 9.81 meters per second squared.
However, what we are actually finding is the value of g, so we will have to change the equation to fit our needs. The pendulum period relationship was first observed by Galileo Galilei. He observed this relation while watching a chandelier swing. From this, Galileo assumed that the length of a pendulum determines its period, which is mostly true.
In 1656, a man named Christian Huygens invented the pendulum clock. It increased clock accuracy from losing 15 minutes a day to only 15 seconds by using a stable period of pendulum to keep time.
For our English component, we decided to choose the journal option because it will allow us to effectively record and reflect upon our progress with the project.
Journaling will be the best way for our group to easily access the material in order to better assess the principle of gravitational acceleration and other excess concepts behind our experiment.
Now for our experiment. The materials we will be using are a string about 1 meter, assorted masses bobs ranging 1 gram to 1 kilogram, a stopwatch, a rod and clamp for a stand, and a meter stick.
We will start assembling the standby, attaching rod and clamp towards a table about 1 meter above the ground. Then we tie selected bob of mass G on one end of the string and tie the other end of the string towards top of the stand.
We will now set the bob 1 meter above the ground set at an angle from pendulum. As you can see, we are pulling the pendulum up to its starting position.
After the mass is set at its starting position, we release the mass and allow it to oscillate to the original position 5 times while recording time using stopwatch.
Using this formula, T equals 2 pi times the square root of L over G, where L is the length of the string, and T is the time it takes for the pendulum to finish one cycle. Period equals seconds for one revolution. To solve for G, we will use the adjusted formula shown earlier.
We will repeat this exact process, except we will change the mass of the bob within 3 trials. We will also repeat the process again, except this time we will shorten the length of the string within 3 trials.
After all the trials were performed, we recorded data on tables and graphs using mass period and length period. Also be sure to record G with each trial. Here are our results.
As you can see, changing the mass of the bob will not change the period of the pendulum. Shortening the length of the string will shorten the period. However, this does not change the value of G. G in both cases remain relatively constant and near the theoretical value of 9.81 meters per second squared. By using the formula of period for a simple pendulum, we were able to find the value of gravitational acceleration.
Thank you for tuning in to Harmony Public Schools.